Now, when we make predictions using our least squares regression line, we can classify these as either being interpolation and extrapolation. Now, interpolation is when we make predictions using values that are between the minimum and the maximum of our data points, right? Now, let's say, for example, that we've got this scatter plot and we use an x value that is between our lowest x value and our highest x value in order to predict a y value, okay? So let's say, for example, we use that x over there. Now, if we use that x over there, our predicted or our estimated or our expected y value is going to be that one there. And that's what we calculate when we do our least squares regression line. Okay, now that's going to be interpolation, and the same goes if we use a y value that is within the range of our existing y values, and the x value that we estimate or predict there would be one that comes from interpolation. So what then is extrapolation? Well, extrapolation is when we use data values that are not within our existing range in order to make predictions, right? So we've got the same sort of thing here, and now instead of using an x value that's within our x min to x max range, we're going to use an x value that is outside of that range in order to make a prediction. So if we use that x value there in order to predict or estimate that y value there, that would be extrapolation. And the same goes for the y values. If we use a y value that's not within the range of our existing y values, and we predict an x value from that using our least squares regression line, that would be extrapolation. So the question is, why do we care? Why do we differentiate between interpolation and extrapolation? The reason for that is that extrapolation is less reliable than interpolation. And I'll give you an example to help you understand this. So let's say that I go to a school and I go and record the age of some of the students and their shoe size. And this is the data that I get, that I go and plot, and my maximum age there was 16. I didn't talk to the grade 11s or 12s. Okay, so that's my data. And then what I do is I go to an office, and there I talk to the people and I ask them, how old are you and how big are your shoes? And I take that data and I go plot it, and I get this information that is there in green. And let's say that I only spoke to people who were between the ages of 16 and 35. Okay. Now, let's say that I go and use my original least squares regression line that I obtained by going to the school. So that's then those pink dots, right? So I'm ignoring the green dots. I'm going to use the pink dots in order to determine a least squares regression line, and then that line I'm going to use in order to make a prediction. Right? So if I use that line and I want to say, if somebody's 35, how large do I expect their shoes to be? Then I'm going to predict that somebody is walking around like this, which is obviously not going to be happening, right? So what went wrong here? Well, what goes wrong is as you grow up, you get older, and then your feet get bigger as well. But at some point, you get older, but you stop growing, and then your feet remain the same size. So even though we had this linear positive relationship for a certain age range, that relationship did not continue for the data beyond 16. And that is why extrapolation is less reliable than interpolation. It is because we do not know for sure that the trend that we have predicted is going to continue outside of the data that we have collected. Let's look at the effect of sample size. Now, statistics that are derived from larger sample sizes are going to be more reliable. Let me show you what I mean. So let's say that we've got these two scatter plots. And for these scatter plots, we have exactly the same correlation coefficient. We have exactly the same least squares regression line. Now, which of these two would we prefer to use in order to make predictions? Well, for the first one, if we go and find more data points, it's not unreasonable that those data points might look like those yellow ones there. And that would actually mean that our true correlation isn't round about 0.9. Whereas for the second one, if we were to go and get some more data points, we expect that it's going to be much closer to what we have there originally, and that's because we have more information that we have used in order to predict that trend. So now it is time for you to pause the video and put everything that we've discussed now to the test.